Today we continue talk this book, Electromagnetic Wave Theory of Photons. Maxwell EM theory is wrong. Maxwell electromagnetic wave theory is wrong. Example 3. Today we will talk example 3. In this example, we think here has a very long circle. We have lines here. Here has this is first core, primary core, and then we think assume here has a second core. This is this A. This is B. It is clear B1 at R equal B equals 0. Actually, B1 are smaller than A. That means inside the first core, that is not there. We all know this is R, this is B1. So B1 will immediately, this is R equal A. So here inside this region is not 0. This is B. However, we know A A is something like this. This is R equal A. R equal A. So R equal B. This A is vector potential. That in the R equal B is not zero. Here is R equal B. Z equals zero. Hence, if we calculate the energy if we calculate the pointing vector, that is S11 equal since if we calculated in R equal B's place, this is zero. That means pointing in the second call, the pointing vector is zero. So if you like to use pointing vector to explain energy flow, that is not possible. So in this case, in all electromagnetic theory, we all try to use another method. E1 and the apron is the EM force. Epsilon equals to is defined by so since here this is not zero, this is also not zero. Is not zero. And this potential equals epsilon. So the power in the second core equals that is not zero. It's clear. This situation is called Maxwell large effect. Maxwell large effect. Similar situation in quantum physics that has AB effect. AB effect is, for example, here has a core is a very long core, and here has a source of electron. The electron will go from above and underneath, come here. Here is a screen, and we will find in the end here has interferes the electron. In this situation is also outside. Here has A is not zero, but B is zero. So the people outside speak about, in this case, A is real. A is more important than B. So in Maxwell large effect and AB effect, in these two situations, in our classed electromagnetic field theory, the people try to use A or induced, use the E equal, this is the induced electric field, use this not zero to explain. However, I said all these is wrong. All these are wrong. Let me explain you why it is wrong. Actually, even S11 equals at B's place. This is 0. However, if we calculate mutual energy, this is we look at this part, because H1 in the R equal B, this is 0. So it is equal this is not 0. We know E1 is not 0. What is H second? This is the second coil that has current. The second coil will create B2. This B2 is produced by I2, is due to the I2. And this B2 is not 0 at R equals B's place. That is clear. That is not 0. Hence, we should use mutual energy. That is mutual energy flows to explain the energy flow. So we can say mutual energy flow or current transfer energy, not transfer, or not the pointing energy. So this is very important. We need to a little bit clarify for simple circuit. There only one battery and resistant. In this case, we can find the energy flow is like this. This is pointing. In this simple situation, the energy transfer by pointing vector. However, for separated systems, for example, this is like a transformer. This energy is mutual energy flow. In this case, transformer and also a tunnel. This is a transmitting antenna or another This is a receiving antenna. Energy, that it should be Sm. Mutual in K flow. Oh, and in another case, for example, here has a light source. Here has a light sink. Light sink is a screen. Oh, it's like a screen. The energy flow from source to sink is also mutual in K flow. That actually is photon. Oh. Ah. So we can say photon equals mutual energy flow. Hence, for simple circuit, Poynting theorem is still okay. Poynting is only okay for simple circuit. Perhaps also for transmitting here the energy flow inside. This is S1. Uh, it is a little bit strange for electromagnetic theory. For this, the simple circuit, or like transmitting lines, still the pointing vector is worked, pointing theory is worked. However, transformer, for antennas that need mutual energy flows to explain, and also for photons also need mutual energy flow. So even now, the theory is not united everywhere. I don't know why this reason. I'm still making research about that, but currently is this situation. After this course, like next course, we will continue talk the mutual energy flow theory and mutual energy flow law. This two is different. Talking about this. This is for next. Okay. See you next time. Thank you very much.